History of Virtual Reality by Briseno-Goggins and Devin Runnels. What is virtual reality? The computer-generated simulation that creates a realistic environment using 3D images, sounds, and sensations that can be interacted within a seemingly real or physical way. Virtual realities work by manipulating the mind through sensory experiences, which can include sight, touch, hearing, and less commonly, smell. Most virtual reality displays today either are on a computer monitor, a projector screen, or on a virtual reality headset, which is also called a head-mounted display. Head-mounted displays are goggles placed over your head with a screen in front of your eyes. More advanced simulations include features that allow for additional sensory information and provide sounds through speakers or headphones. The lead up to today's virtual reality technology. The 19th century. In the 19th century, panoramic painting gave the illusion that the viewer was at the event detailed around them. 1838. In 1838, Charles Wheatstone discovered that the brain processes a two-dimensional image seen in each eye into a single image that appears in three-dimensional. With this discovery, he created the stereoscope. 1929. Edward Link in 1929 created the Link Trainer, which is the first flight simulator and was entirely electromechanical. The simulator used techniques that gave the illusion of turbulence and disturbances while flying. Being a safer way to train pilots, the U.S. military bought 6 of these devices. 1939. William Gruber created the Viewmaster based on the stereoscope. 1958. In 1938, Antonin Artaud described the illusionary nature of characters and objects in the theater as la réalité virtuelle. In a collection of essays, Les Derecha et son double, the English translation of this book, published in 1958 as The Theater and Its Double, is the earliest published use of the term virtual reality. 1962. Morton Haig, a little later in history, wrote in the 1950s Experience Theater that painted the picture of a virtual reality could encompass all of the senses in an effective manner, thus drawing the viewer into the on-screen activity. He followed up his words with a built prototype of his vision by the name of the Sensorama in 1962, with 5 short films displaying and engaging multiple senses: sight, sound, smell, and touch. Predating technology in digital computing, the Sensorama was a mechanical device. 1968. In 1968, Ivan Sutherland with help created what is widely considered to be the first virtual reality and head-mounted display system. It was primitive, both in terms of user interface and realism, and the head-mounted displays to be worn by the user was so heavy that it had to be attached to the ceiling. The graphics of the virtual environment were simply wireframe model rooms. 1991. The Virtuality Group launched a range of arcade games and machines in 1991. Players would wear a set of virtual reality goggles and play on gaming machines with real time, less than 50 millisecond latency. Immersive, stereoscopic 3D visuals. Some units were also networked together for a multiplayer gaming experience. 1993 and 1995. Now, in 1993, Sega announced the release of the Sega Virtual Reality headset for the Sega Genesis console. The wrap-around prototype glasses had head tracking, stereo sound, and LCD screens in the visor, although the headset was never released due to technical difficulties. In 1995, Nintendo Virtual Boy, Virtual Reality 32, was released. It was a 3D gaming console that was hyped to be the first ever portable console that could display true 3D graphics. They were discontinued after a year due to the lack of software support, color in the graphics, and discomfort while using.
The Oculus Rift is a VR headset that came out in 2016 that pairs to a PC laptop and Xbox One console thanks to Windows 10. The headset contains two images side by side, one for each eye, same as the setup for a stereoscope. A set of lenses are then placed on top of the screens, which helps focus and reshape the images and creates a stereoscopic 3D image. The headset has embedded sensors that monitors head motion and adjusts the image to the user's motions so the image isn't distorted. The Oculus Rift specs include the 2160 by 1200 OLED display, 110-degree field of view with a 90 Hz refresh rate, a built-in accelerometer, gyroscope, magnetometer, 360-degree positional tracking that follows 6 axes of movement with a latency of milliseconds. Also, an ARM Cortex-M3 microcontroller with 72 MHz CPU. The accessories include the sensor remote, cables, and Xbox One controller. The Oculus Touch controllers are also available. What can VR headsets be used for? Video games. Some virtual reality systems used in video games can transmit vibrations and other sensations to the user via the game controller. The world of virtual reality allows for an opening of the mind to see lifelike experiences. A world can be built where anything is possible, such as games that take place in fantasy settings, where gamers can use abstract fictional telekinesis powers and magic. Medical training. An experiment was performed by 16 surgical residents where 8 of them went through a particular practice through virtual reality training. They then came out 29% faster at gallbladder dissection than the controlled group. With the increased commercial availability of certified training programs for basic practice skills training in virtual reality environments, students have the ability to familiarize themselves with the exact necessary skills in a corrective and repetitive environment that contains the pressure of reality. Virtual reality is also proven to help students familiarize themselves with skills not specific to any particular procedure, which in fact does way more than any book could ever do for a person.
With HoloLens, you can see the muscles on top of the skeleton all at the same time. You can bring them in and out and exactly understand where things sit.
You can take any anatomical part and show any of it. You can move it around, you can make it kind of translucent so you can see through the outside, and that really helped me understand how cardiac anatomy worked. I actually had a moment where I found the aortic valve, and it was the first time that I'd actually seen the aortic valve in relation to all the other anatomical structures. It was a way of seeing it that you couldn't do with an actual heart.
I think this will improve students' confidence in learning anatomy dramatically.
By creating simulations with the HoloLens that lets them have an experience where they can fail, that would be the best way to learn, because we don't allow people to fail too much in real-life medicine.
With HoloLens, you could imagine having a class standing around a model, almost like a tour group in a museum, where they're all interacting completely naturally. I spend a huge amount of time to make sure they become the best professionals, because it's all of our jobs to make the world a better place.
Working with Case Western Reserve University to create this paradigm shift so that we can leap together with students into the future of education. We believe that HoloLens is going to enable us to do that.
We talked about being able to use it to teach art history. We have an anthropology department too that I think will enjoy this technology.
Anytime you change the way that you see things, it changes the way that you understand them. As soon as you can change somebody's understanding, then they can change the way they see the world.
Military training. VR allows the recruits to be fully tested in training under a controlled environment where they are respond to different types of combat situations. A fully immersive virtual reality that uses head-mounted displays, data suits, data gloves, and virtual reality weapons are used to train for combat. This setup allows the training's reset time to be cut down and allows more repetition in shorter amount of time. In return, creating better, more efficient soldiers. The fully intense training environment allows the soldiers to train through a wide variety of terrains, situations, and scenarios.
Military training technology out there, the Dismounted Soldier Training System, which is the first virtual reality training system for US military infantrymen.
Call of Duty or anything as nice and slick as it is, it's more meant for a casual gamer that doesn't necessarily have any kind of military experience. This is an actual simulator that you use to train with.
Dismounted Soldier Training, just one of the ways the US Army is developing the 21st century American warrior. It's a $57 million system, unveiled for the Army over the summer by a company called Intelligent Decisions. Soldiers train for real-life combat scenarios in a virtual space.
So you can go into this system and train on any kind of environment, urban, woodland, desert, depending on the needs of the leadership and what they want to train for.
So I decided to strap up and give it a go. I feel like I'm like Bane or something.
The tools for this system, the main components are the head-mounted display. This supplies the visual stimulus.
Head, arm, and leg sensors detect your motion.
So whatever it's coded to be, whether it's coded to be a grenade or binoculars or whatever. So you hold it there, it activate, and you just make the motion of throwing the grenade, and then you'll throw a grenade.
To move in the virtual space,
The only thing you don't actually have to move your feet. I turn my head to look around in the environment. I turn my body to move my body in the environment, but the actual act of walking or running or crawling, there's a joystick on the front hanger up of the weapon, and that's how you move it.
As for the gun,
there's a sensor on the buttstock, so when you're calibrating, it registers when you bring it up.
When you press it against your shoulder, the scope appears. The 15-pound backpack processes each action, sending soldiers' data out to a network so they can operate as a team.
One dead bad guy in the hallway.
Guys outside the village are armed too.
You're talking to each other, you're moving in real time, you're seeing what they do, they see what you do, just like you would in any other kind of virtual environment.
Although it seems like a video game, virtual missions can make live training more efficient, saving time and money.
Go ahead and stand by on Alex and the captain.
Boot a scenario up, they can run through it, and then if they say, oh, let's try that again, it's basically just a matter of a few clicks and you're reset. There's not moving everybody back into position, there's no repositioning of vehicles, there's no fueling up. Right there you're saving money, time, fuel, ammunition.
So when they do have those reduced live rounds and they go into a live house, shoot house, they get the maximum out of it.
Computerized training also allows commanders to insert unforeseen obstacles and enemies into the mission, testing the versatility of their soldiers.
There's a lot of flexibility as to what can be done in the scenario as it's going on. As the operator, we can sit there and the leadership would say, hey, can you put this such and such here? I want to see how they react to it.
All the insurgents have been eliminated.
Finally, it's mission accomplished. Very, very cool. Very realistic. You can hear everything, even the birds squawking. I think one of the bad guys even talked smack to me before I pop in. Then the troops undergo AAR, After Action Review.
We have it recorded. We go over to the AAR machine and the squad, the fire team, whoever's training in it can sit down, look up, and you have the leadership going with them point by point, minute by minute on what was going on.
And that's central to building the modern-day American soldier.
Nothing's going to take live training away from the soldier completely, but as we move forward into the future, the military, everybody's trying to do things to make their processes more efficient, both cost-wise and time-wise.
For The Daily, I'm Alex Dickinson.
Devices such as HTC Vive, Samsung Galaxy Gear, Microsoft HoloLens, Google Cardboard, Sony PlayStation VR, Google Daydream View, Razer OS VR HDK 2, and the Fog VR are some of the devices that are out today for virtual reality. Other capabilities such as roller coaster rides, movie, show, concert watching, scenery such as walking around Paris in space, test driving, and other simulations are available through VR.